Jhunjhunwala from IIT Kanpur. So today I'm going to discuss units and measurements chapter with you all. So let's start. So firstly, talking about units and measurement, why we need units? We need units to measure some physical quantity like length, mass, and time. So just to measure these quantities, we require units. And for example, the unit of length is meter, and the standard length of 1 meter has a precise definition. Like we know now that 1 meter scale is standard. So that's why we need units to measure the physical quantities. So to measure the length of an object, we need to determine how many times the standard meter is contained in the length of the object. That's what we say that if there is a distance of 13 meters between 2 points, so we need to apply meter scale 13 times between those 2 points to measure the length. That's what it is written here. Ki we need to measure the required length in some standard units, which in case of length it is meter. So the comparison of a physical quantity with a standard quantity is called measurement. Then moving ahead, what are physical quantities? Physical quantities are something like length, mass, time, the quantities which you use in your daily life. Those quantities we measure using some standard units. Those quantities are known as physical quantities, like which can be measured in simple sense. A physical quantity is one that can be measured. Okay, so this is one thing, and then thus length, mass, time, pressure, temperature, current, and resistance are considered as physical quantities. Okay, so this is one thing. Then classification of physical quantities. Now there are two types of physical quantities as it is written here: fundamental quantities and derived quantities. So basically, what are difference between fundamental and derived? Fundamentals are those which we use to derive derived quantities, like the physical quantities that are independent. Sorry, the physical quantities. Let me erase it. The physical quantities that are independent of each other are called fundamental quantities. So all the other quantities which can be expressed in terms of fundamental quantities are called derived quantities. Okay, so those quantities which are independent of each other are fundamentals, and those quantities which we derive from the help of some fundamental quantities are known as derived quantities. It is something like using something to frame something else. So that thing which we are using are fundamental, and that thing which we are making are derived quantities. So coming on to properties of units, the unit should be of some suitable size. Like we know that 1 meter is of some suitable length. Uh, 1 meter is something which is very standard, which is very fundamental. We define 1 meter, we know how much 1 meter is. So they are of suitable size, they are well defined and easily reproducible. Matlab, they cannot, it should not change with anything. It should not change with place, it should not change with time. Like 1 meter is 1 meter only. It will not change if you go to somewhere else, it will not change with any time. So it is one thing. Then that's what it is here. The unit should be easily reproducible and it should not change with time. Then it should not change with physical conditions like temperature, pressure, etc. All these things, coming. Then it can be compared experimentally with similar physical quantities. All these things like meter can be compared with kilometer because 1 kilometer is equal to 1,000 meters. All such things. Then units are also of two types: fundamental and derived. Derived are those which can be derived from using fundamental units. So these are like not very useful, but yeah, you should know the definition. Then coming on to this thing, this is very important. System of units is very important. So basically, there are four types of system: FPS system, CGS system, MKS system, and SI system. Among these, the most useful system is SI system, which you will be using in your entire physics. So SI system is the most important one. Now discussing one by one. FPS system. In this system, the unit of length is foot, unit of mass is pound, and unit of time in second. So basically, when after a few slides, you will also learn what are dimensions. So in dimensions, also you try to define the dimension of any quantity using preferably these three quantities, which is mass. length, and time. Using preferably these three quantities, you try to define the dimension of each and every quantity. So that's why in each and every system, we also try to define each and every system with these three quantities only. So like in FPS system, unit for mass is pound, unit for length is foot, and unit for time is second. That's why it is known as FPS system. F for foot, P for pound, and S is second. Similarly, in CG system, this is also used very much. Like in India, we use SI system and CG system a lot. So in CG system, the unit of length is centimeters. As it is written here, the unit of mass is grams, and the unit of time is second. There's one thing common in all the four systems: the unit of time is second only in each and every system. So that's not which differs in any unit system. The things which differ are mass and length. So then coming on to MK system, in MK system, unit of length is meters, unit of mass is kilograms, and unit of time is seconds. Okay, then the most widely used measurement throughout the world, as it is written here, why it is SI system. Why the full form of this thing is System D International System, which means this system is used worldwide. Like whenever there is some ambiguity in measurement of length and mass, we try to use SI system, so that SI system is something which is common everywhere. So if in SI system in India you are getting length as 3 meters, then in any other place also you will get length as 3 meters only. That's why it's something like common. The common system which we use in entire world is SI system, and in SI system, with the all fundamental quantities have their fundamental units, like mass is of kilogram, length is of meters, time is of seconds, and something like that. The system is based on seven basic units and two supplementary units. So these were the system of units. Now some basic units, like these are all for SI system only. SI system. Okay, so for length it is meter, for mass it is kilogram, for time it is second, for temperature it is Kelvin, for current it is ampere, for number of particles it is mole, for luminous intensity it is candela, and one thing, candela CD is small, all others are capital, like Kelvin is capital, ampere is capital. So please remember the units, which one is small and which one is bigger, because these also contribute a lot towards this units chapter. So please remember this thing. Then coming on to angle part, there are two units, radian and steradian. Radian for plane angle and steradian for solid angle. So this you must learn. Okay. So now coming on to dimensional formula analysis. Dimensional analysis. So dimensional analysis are very much used when we study this chapter, because not only in this chapter, in upcoming chapters also when you will carry out the answer of something, some formula or something like that. If you don't know the exact formula and you know that you are going to derive something related to energy, then you can compare the units of your answer with the dimension of energy. If the dimension of energy and the units of your answer are matching, then you can say that you are heading towards the right path. So basically, dimensions are very useful because these are something like you can use to check your answers even in any further upcoming chapter. So please focus on this thing. This is very important. The dimension formula of any physical quantity is the formula that tells which of the fundamental units have been used for the measurement of that physical quantity. Okay. So how is dimensional formula written for a physical quantity? The formula of a physical quantity must be written first thing first. Then the quantity must be on the left hand side of the equation. All quantities on the right hand side must be written in terms of fundamental quantities like mass, length, and time. As I earlier told you also, for deriving any fundamental quantities, you use mass, length, and time preferably. You use other things also, but mass, length, and time must be used. Then we replace mass, length, and time with MLT as their standard symbols, and then we write to the power of these terms. Like if there is kg square, then we write m square. If there's length power half, then we write L power half, and some things like that. So moving on to characteristics, dimension do not depend on any system of units. One first thing, then because it is dimension of any quantity would be same either in CGS or SI or FPS or MK system. In each and every system, dimension will be same. Dimension will not differ. Then quantities with this thing is very much useful for solving questions. These properties, quantities with similar dimensions can be added or subtracted. Like you cannot add or subtract energy with a force. You can only add and subtract two forces, or you can only add and subtract two terms of energy. So only terms with similar dimensions can be added or can be subtracted. So this is also a very important thing. Then dimensions can be obtained from the units of physical quantities and vice versa. Then two different quantities can have the same dimension, obviously बात है. Like you can say that energy and work both are different quantities. We say that work is an organized form of energy, but both the quantities have same dimension. So it is not such like any quantity will only have one dimension. Like मतलब, one dimension will be for one quantity only. It is not like that. Many quantities can have the same dimension. Then when two dimensions are multiplied or divided, it will form the dimension of a third quantity. Obviously बात है ये तो, क्योंकि let's say one dimension is given to us. I'm taking any random dimension. One is given to us ml square, and another is given to us as mlt. So when you are dividing these two, you will get a third dimension, which is m and m will cancel. You will get l t minus one. Okay. So basically, using two dimensions of two different quantities, you are getting a third dimension. So that's what it is written here. When two dimensions are multiplied, sorry, when two dimensions are multiplied or divided, it will form the dimension of any third quantity. So this is also very important property. Second and fifth are very important properties. So please remember them. Okay, so moving ahead, dimensional analysis. Now, dimensional analysis के लिए हम लोग when we use dimensional analysis, we use preferably for doing three things: checking the correctness of equation, which I told you as I started dimensional analysis. You want to check your answers so you can compare the dimensions of your answer to the dimensions of the required quantity. If you are calculating energy and the answer which you are getting, you can compare the dimensions of your answer with the dimensions of energy so that you can check the correctness. Then converting the units of physical quantity from one system to another, you can use it because in each and every system dimensions are same. That's why. And then deduce the relation by connecting the physical quantities always. Okay, so now some basic dimensions are given for some basic physical quantities, like displacement is measured in terms of length, so in meters, and meters means L power 1, and mass and time will have 0 as their superscripts because it is only measured in length. So it is L power 1. Area is length square, so it would be L2, M0, T0. Volume is length cube, so it would be L3, M0, T0. Velocity is meter per second, like velocity is what? Velocity is distance upon time. So distance is measured using length upon time. Time is measured using t. So it would be lt minus one. That's what is written here. Lt minus one m0. Acceleration is distance upon time because it's velocity upon time. So writing it roughly, it would be l upon t square because basically we are dividing velocity by time. So this is velocity, we divide by time. So one more t in denominator, so l by t square. So my answer would be m0 l1 t minus 2. Then density is what? Density is mass upon volume. Mass upon volume, and volume is L cube. So M L minus 3 T0. Then momentum, what is momentum? Momentum is mass into velocity. Mass into velocity, and velocity is L by T. So it would be M L by T. And ML by T is nothing but M1 L1 T minus 1. That's what it is written here. Then work, energy, heat. All these things we know that it is mass multiplied by force. And force is what? Force is displacement into like mass into acceleration. Mass into acceleration. Acceleration is L upon T square. So this is force. And when we multiply force by distance, we get work. So it would be ml squared T squared upon T square. So ml2 T minus 2. Okay. Then power is work upon time. So divide it once again by time. So it would be m L square divided by t square तो already था, and since it is power, so we will divide it once more by time. So we will get t cube. So it would be m L2 t minus 3. Okay. Then moving on to angular velocity. Angular velocity is radian per second, and radian is measured in terms of theta. So theta has no dimensions, but per second it is 1 by t. So time has dimensions. So it would be m0 L0 t minus 1. Radian has no dimensions because angle has no unit. Then angular acceleration, it would be same. It would be radian per second square. So it would be m0 L0 t minus 2. Okay, so moving ahead. Okay, now moving on to principle of homogeneity. So what is principle of homogeneity? According to it, all the terms of in a given physical quantity must be the same. That is, S is equal to ut plus half at square. So since we are adding two terms, so we already read that we can add and subtract only two terms of same dimension. Like for energy, we can add energy, we can add force, but we can't add energy to a force. So basically, when we are adding two terms, the dimensions of both the terms should be same. And so here, since it is L and L is coming by adding these two terms, so dimensions of all these two terms also should be equal to L. We know that U is velocity, velocity is Lt minus 1 multiplied by time, which is T. So T minus 1 and T will cancel, you will get L. L is equal to L. This is okay. Now check the dimension of this thing. Dimension of acceleration is Lt minus 2 and dimension of T squared is T2. So again, you will get L only. So L is equal to L plus L. So it means that dimension are satisfied. So you can easily do this thing. So whenever you want to check any equation, you use dimensions. If dimensions are coming same, then only you can add or subtract anything. Okay. So while deriving the formula, the proportionality constant cannot be found. There are defects of dimension analysis also. You can't found the exact value, but you can just compare the dimensions. The equation of physical quantity that depends on more than three independent physical quantities cannot be reduced because we use mass, length, and time only. Then this method cannot be used if the physical quantity depends on more parameters and all things like that. Because equation contain trigonometric functions and exponential functions cannot be read because we are using only mass, length, and time. That's why. Okay, now coming on to significant figures. So significant figures are basically something by which you get to know the very correct answer. Like 2.00001. So basically, if you will say it like a layman, you will say that answer is coming out to be equal to 2. But if you want your answer to be at most correct, to be correct very much, so you will say 2.00001. That's what significant figures tells us. Significant figures tells us that the degree of correctness of an answer. So if you want your answer to be correct to three decimal places, so you will say 2.0001, something like that. So that's what significant figures are in very much used because like some there are many things which whose price is very much like 10 grams gold is of very huge quantity, so you will not say 0.010 kg, you will say 10 grams because 10 grams gold has very huge amount. So when you want to know each and every bit of something, you use significant figures. So how to calculate significant figures, there are a lot of rules for that. So I have written some of them here, so let's read them one by one. So first is all the non-zero digits are considered significant. Like uh, just regarding zeros, all the non-zero digits, be it positive or negative, they are all considered to be significant. Then rule two. What is rule two? Rule two is zeros which are placed before non-zero digits are significant. Like if it is written 0.001, something like that. So you will say that both these two zeros are significant. Okay, I'm not talking about the zero which is before decimal, but these two zeros are significant. Zeros which are placed before non-zero digits are significant. This is another rule whose title is self-explanatory. Zeros are not significant according to a significant digit rule. Then rule three: a final zero in the decimal position is significant, whereas a leading zero is not. That is, this zero is not significant, but 0.0010. So this zero is significant. Okay, so zero which is coming after the number in a decimal, that is significant, but the previous zero is not significant. Any amount of zeros trailing in front of a number is not regarded as a significant digit and is therefore non-significant. So listed below are major figures, guidelines that regulate the use of significant figures. The non-zero digits are important, first of all, because those are significant. There are four significant figures in this thing because all the four are non-zero numbers. And there are three significant figures in this because the zero is disregarded, as I told you. So only three significant figures are there. Then, in the absence of any preceding zero, the non-zero digit is of no consequence. Only one decimal point may be seen in the number listing, but there are three in the number listing. So what I'm basically saying is here only three are significant and here only one is significant. Only five is non-zero number and two, three, two are non-zero numbers. So there are five significant digits in 4.5006 because, as I told you, both 5 and 6 are significant. So the zeros between them will also be significant. So there are five significant figures in this number. Okay. So these are some rules, and there are many more rules for significant figures, which you have to read through your book or something like that. So significant figures are like very useful for your JEE main content, especially because they contain a huge lot of marks. Well, not lot of marks, but if you're in your JEE-Main paper, it is a huge possibility that if a question comes from unit and dimensions chapter, so it might be from significant figures. Like they will give you a number and tell and ask you how many significant figures are there. So this you must read significant figure rules from your book because they are a slight important. Coming on to least count is something like when you measure, like taking about your 15 centimeter scale. You use your 15 centimeter scale in your school. So what is the minimum length which you can measure using a device? Like from a 15 centimeter scale, how much you can measure minimum? So at minimum you can measure 1 mm. You know that in each and every centimeter on your scale there are 10 lines, where the fifth line is bigger and all of the 9 lines are smaller. So minimum measurement which you can make using a device is known as the least count. So using a 15 centimeter scale, you can measure at least of 1 mm. So this is the least count of a 15 centimeter scale. That's what it is written here. The least count of an instrument is the smallest measurement that can be taken accurately with it. The least count of the meter scale is 1 mm, as I told you, and that of the ammeter is 2 ampere. So ammeter ka least count 2 ampere hota hai. This you must remember. Then measurement of length with a meter scale. In daily life, the length is measured with the help of a meter scale. It's graduated in centimeter and mm and all those kind of stuff, you know. But basically, what is the definition of least count is the minimum measurement which you can do using a scale, using any device. Okay. Coming on to errors. So error calculation is also a very important part of this chapter. So basically there are three types of errors: absolute error, percentage error, and relative error. So what is absolute error? Absolute error is the difference between the measured value of quantity and the actual value. Like if your actual value is 5 centimeters and your answer is coming to be 4.9, so 4.9 minus 5 come out, because absolute error, as the name suggests, is always positive. So if your answer is 5.1 or 4, or 4.9, both will give you zero point 0.1 as an absolute error only. So basically, absolute error is the mode of the measured value and the actual value. Difference between the actual value and the measured value. When we take the mode of that thing, we get absolute error. Okay. And what is percentage error? When we divide absolute error with the original value of the quantity and multiply it by 100 to get the percentage, we get percentage error. Okay. And relative error is nothing. You just avoid this percentage, you will get relative error. So basically, this is actual minus measured. This is actual minus measured divided by actual into 100 for percentage. And when you want only relative error, you don't want percentage. So you remove this into 100, something like that. Okay. So this was all about errors. Moving ahead. Okay. So coming on to questions. 1 second. Okay, so now let's start with questions. The dimensional formula for relative refractive index is what? Okay, so we know that the formula for refractive index is represented by mu na. So mu is equal to velocity of light in air upon velocity in your medium. So basically this is represented by c. I wrote it v, sorry. It's basically c upon v. So it would be c, which is speed of light in air, divided by speed of light in the medium. So since both are speed of lights, so speed is nothing but velocity is lt minus 1. So above also there would be lt minus 1, lt minus 1, and denominator also would be lt minus 1, because both are speeds only and the dimension of speed is lt minus 1. So both will cancel and you will get a dimensionless quantity, that is m0 l0 to 0. So the relative refractive index is the ratio of refractive index of the medium Okay, I wrote refractive index, but relative refractive index is the ratio of refractive index of the medium to refractive index of the vacuum. So make it a concept from now that whenever you divide two same quantities, so the answer which you will get which will be dimensionless. That is, the dimension would be m0, l0, t0. Because since you are doing the ratio of two similar quantities, so both the quantities will have same dimension, so they will cancel, and your final answer would be dimensionless quantity. So like in this case, m0, l0, t0 is your final answer because you are dividing two same quantities, which is refractive index of medium and refractive index of the vacuum. Since both are refractive index only, you will get a dimensionless quantity. And here I told you about refractive index because in refractive index you divide the speed of light with speed of light in vacuum with speed of light in medium. So again, both are speed only, so you will get a dimensionless quantity. Okay, so your answer would be B part. Moving ahead, let me shift to the side. Okay. So a thin copper wire of length L meters, it is 1 meter, L meters, okay, increasing in length by 2% when heated to 10 डिग्री सेल्सियस. ओके, सो ये अपने को पता भी है, जैसे अपन लोग पढ़ते भी है कि अपन जब किसी चीज को हीट करते हैं तो उसमें थर्मल एक्सपेंशन होता है. सो बेसिकली मैं यहाँ पे एक वायर को हीट कर रहा हूँ जो उसकी लेंथ L मीटर्स थी, तो वो हीट करने से 2% इंक्रीज हो रही है when heated through 10 डिग्री सेल्सियस. सो मुझसे पूछा क्या है, मुझसे पूछा है व्हाट इज द परसेंटेज इंक्रीज इन द एरिया व्हेन स्क्वायर कॉपर शीट ऑफ लेंथ एल इज हीटेड टू 10 डिग्री सेल्सियस. तो मेरे को बेसिकली उसकी लेंथ में इंक्रीज दिया है और मुझको एरिया में इंक्रीज बताना है. ठीक है. सो ये मुझे पता रहता है मेरे एक्सपेंशन वाले चैप्टर से कि जो लेंथ में एक्सपेंशन होता है उसमें लिखता हूँ डेल्टा एल इक्वल टू एल अल्फा डेल्टा टी, वे अल्फा इज द कोफिशिएंट ऑफ थर्मल एक्सपेंशन, लीनियर एक्सपेंशन. For area, we use beta, which is superficial expansion. For volume, we use gamma, which is volume expansion. This, I think, you must have read in the expansion chapter, thermal expansion. So, since we are given delta L is 2%, so delta L by L would be 2 by 100. That should be equal to alpha delta T. From there, delta T is 10 degrees Celsius. So, here it would be 10 only. 100 is written wrong because it is heated by through 10 degrees Celsius, so it would be 10 only. It is not 100. So from here you will get alpha equal to 2 by 1000 because 100 into 10 is 1000. So you have calculated alpha and you know the relation between alpha, beta, and gamma. Alpha beta is equal to 2 times alpha. You know this thing, and if you gamma was also given, then gamma is equal to 3 times alpha. So these are the relations which you study in thermal expansion chapter. So if you don't know, so please remember this thing: beta is equal to 2 times alpha and gamma is equal to 3 times alpha. So use beta equal to 2 times alpha. From there you will get beta. So use beta in your solution. Delta A upon A is equal to beta delta T. Beta is 4 by 1000. Delta T is again 10 degrees Celsius. So from there you will get delta A upon A. So delta A upon A is what? This is relative error which I told you. When you divide your absolute error with original value, you will get relative error. But what is asked to you? They have asked you percentage increase. So you need to tell the percentage error. So multiplied by 100, so your answer would be 4%. Okay. So basically this thing was in this chapter. One more thing is there. You need to know the concepts of other chapters to implement in address and something like that, because this is not an individual chapter. This chapter comes in use with other chapters. So if you don't know this concept of beta and gamma, superficial and volume expansion, that this thing is equal to 2 times alpha and 3 times alpha, so you would have not done this question. So please, this chapter is actually easy, but you need to know the concepts of other chapters also. Moving ahead, the period of oscillation of simple pendulum in the experiment is recorded as this thing. Okay, so आपको different period of oscillations दे रखे हैं. इस simple pendulum का हमने experiment किया lab में, and we recorded period of oscillations as 2.63 seconds, 2.56 seconds, 2.42, 2.71 and 2.80 respectively. So मुझसे average absolute error पूछी है. एवरेज कैसे निकालते हैं? जैसे निकालते हैं वैसे निकालेंगे. सारी क्वांटिटीज का एब्सोल्यूट एरर निकालेंगे, उनको ऐड करेंगे और डिवाइड बाय नंबर ऑफ क्वांटिटीज कर देंगे. तो सबसे पहले तो मैं एवरेज वैल्यू निकाल देता हूँ. जो इसके एवरेज वैल्यू होगी इन सबकी, वो मेरी ओरिजिनल वैल्यू होगी ना. तो ओरिजिनल वैल्यू मुझे दी हुई नहीं है, तो ओरिजिनल वैल्यू निकालने के लिए मैं क्या करूंगा? आई विल टेक द एवरेज ऑफ ऑल दीज वैल्यूज. So taking average, adding all these and dividing by 1, 2, 3, 4, 5. Dividing by 5, I will get the average value, and this average value is my original value. That is 2.62 seconds is something original value for my period of oscillation. Now I will calculate absolute error using original minus measured, and I will take the mod of that thing because absolute error is always positive. So 2.63 minus 2.62, 0.01, 2.56 minus 2.62, mod 0.06. In that way, I will calculate all 5, 0.01, 0.06, 0.20, 0.09, and 0.18. Okay, and then for calculating the mean, I will add all these 5 quantities and I will divide it by 5, that is the total number of quantities. So I will get 0.108 and I will round off to 0.11 because only these type of answers given to me. So I rounded it off and my final answer is 0.11 second. Okay, so average is calculated in the similar way. You add all the quantities and divide by total number of quantities, you will get your final answer. Okay, so moving ahead. In this question, it is given the density of a solid ball is to be determined in an experiment. Okay. The diameter of the ball is measured with a screw gauge. Okay, screw gauge इसमें use किया. Screw gauge का principle आपको पता होगा, नहीं पता तो फिर मैं I will tell you in this question. Whose pitch is 0.5 mm and there are 50 divisions on the circular scale. Okay. So तो जो मेरा स्क्रू गॉज होता है उसमें जो लीस्ट काउंट होती है वो उसका फॉर्मूला होता है पिच अपॉन नंबर ऑफ डिविजन ऑफ सर्कुलर स्केल. तो अगर ये नहीं पता तो उसको याद कर लेना. लीस्ट काउंट इज इक्वल टू पिच अपॉन सर्कुलर स्केल डिविजन्स व्हिच इज 0.5 mm divided by 50. So 0.01 mm is my least count. ठीक है. So this is the minimum error which you can do using this scale. So the reading on the main scale is 2.5 mm. मेरे को 2.5 mm दी हुई है मेन स्केल की रीडिंग. और क्या बोला है मुझे सर्कुलर स्केल पे 20 डिविजन आ रहे हैं, मतलब 20 into 0.01 ये मेरी सर्कुलर स्केल की रीडिंग है. तो बेसिकली मेरी टोटल रीडिंग कितनी हो गई? मेन स्केल रीडिंग विच इज 2.5 mm प्लस जो मैं लीस्ट मेजर कर सकता हूँ सर्कुलर स्केल से वो है 0.01 इंटू टोटल कितने डिविजन आ रहे हैं सर्कुलर स्केल पे 20 डिविजन आर टोटल डिविजन विच आई कैन मेजर ऑन सर्कुलर स्केल. सो 0.01 into 20 plus 2.5, so my answer would be 2.7 mm. Okay, so 2.7 mm is my answer for screw gauge reading. Then what they're asking me? They're asking me if the measured mass of the ball has a relative error of 2%. अच्छा, तो मेरे को इस केस में एरर दी है और मुझसे परसेंटेज एरर पूछा है. Relative measured mass of the ball has a relative error of 2%, then the relative percentage error and the density. अच्छा, मुझे मास में दिया हुआ है, मुझे डेंसिटी में पूछा है. ठीक है, तो मैंने इसका वो तो निकाल लिया कि इसकी जो उसमें लेंथ में क्या एरर होगी वो मैंने निकाल लिया. 2.7 mm मेरी स्क्रू गॉज की रीडिंग आ रही है. तो डेंसिटी का फॉर्मूला क्या होता है? डेंसिटी का फॉर्मूला होता है मास अपॉन वॉल्यूम. क्या फॉर्मूला होता है? मास अपॉन वॉल्यूम. और मैं वॉल्यूम को क्या लिख सकता हूँ? वॉल्यूम को मैं लिख सकता हूँ मास. वॉल्यूम इज 4/3 पाई आर क्यूब. सो 4/3 पाई एंड आई की जगह आई कैन यूज d/2, diameter by 2. So diameter by 2 because radius is half of diameter ka cube. Okay, so from here I can write my error in density, which is delta rho by rho. I'm writing the relative error, so it would be delta rho by rho. This would be equal to delta m by m, delta m by m. And errors, we don't take negative signs, we always take positive sign because we want to calculate the maximum which can be done. So delta m by m for this mass plus 4/3 pi and 2 are constant, so there would be no error in these quantities, only error would be in diameter d. So plus delta d by d, and we will multiply it by 3 because since it is raised to power 3, so error can be 3 times. So plus 3 times delta d by d. This is my relative error in my density. 3 times delta d by d. Okay, so delta m by m is giving to me how much? 2% error in mass. So 2%, 2 by 100 is 0.02, 0.02 plus 3 times delta d by d. And delta d by d I have calculated using screw gauge. It is 2.7 mm. So d is 2.7 mm. And delta d is the minimum error which I can do in measuring this thing. It is 0.01 because least count is 0.01 and the least count is the minimum error which I can do. So 0.01 upon 2.7. Okay. So from here what I will get? Let me check it. I will get 1 second. 0.01 divided by 2.7 into 3 plus 0.02. So I am getting something around 0.031. 0.031. Okay. And I know that I want it in percentage, so I will multiply it by 100. So I will get 3.1% as my final answer. Okay. So I hope you got this concept. Delta m by m, delta rho by rho is equal to delta m by m plus 3 times delta d by d. We only take positive sign because we want to calculate the maximum error, and we multiply it by 3 because it is raised to 3 power. Delta d is 0.01, which is the least count of the screw gauge, divided by d, which we calculated as 2.7 mm, and added 0.02 because it is given to me that relative error is 2%. So I divided by 100 to get the delta m by m, and from there I got delta rho by rho. Relative error is this much, and I want percentage, so I will multiply it by 100, and my final answer would be 3.1%. Okay, so I hope you got it. Let's move ahead. Okay, so in this question, the physical quantity is given to me as a square b cubed upon c root d, and percentage errors are given to me, and I need to calculate the percentage error in p. So this question is a very, very, very common question in JEE Mains. It is asked again and again. So this will be done in the same way. I will calculate relative error and then multiply it by 100. So delta p by p is equal to 2 times delta a by a plus 3 times delta b by b plus delta c by c plus, since this root means power half, so plus half times delta d by d. ठीक, so यहाँ से अब बस मैं वैल्यूज डाल दूंगा. मैं सबको 100 से मल्टीप्लाई कर दूंगा क्योंकि मुझे परसेंटेज एरर चाहिए. So it would be 2 into percentage error in A, which is 1%. So 2 into 1 would be 2 plus 3 into the percentage error in B, which is 2%. So 3 into 2 would be 6 plus percentage error in C, which is 3%, plus half times percentage error in D, which is 4%. So 4 by 2 is 2 only. So my percentage error in P would be 6 plus 3, 9, 10, 11, 12, 13. So my percentage error in P would be 13%. So 13% is my final answer. Very, very simple question coming from units and measurements chapter. So this is the very basic thing which you must know how to calculate percentage. Okay. So moving ahead. Match list one with list two. Okay, so I need to match the list. So let's do it one by one. Talk is what? So as I told you earlier, also for solving units and measurement chapter, you need to have the concepts of other chapters in your mind. So what is torque? Torque is nothing but force into like if you don't know torque is the something which is a rotating effect of force. Like let's say this is a rod and here you are applying force and your rod is let's say hinged at this point. So basically you will calculate the rotating effect, like how this force is causing rotating effect, and your rod is coming somewhat here, or it is rotating like this thing. Okay, so how to calculate torque? Torque is nothing but force multiplied by the distance from the hinged point. So it is force into length, and force is nothing but mass into acceleration. So mass would be measured in kgs, and acceleration would be measured in meter per second square. So kg meter per second square into length is meters. So the answer would be kg meter square second minus square. And for force, we know that the unit of force is Newton. So they are basically saying that kg meter per second square, they are taking it as Newton. So the answer would be Newton into meters. So nm is third option, so it would be A1. Okay. Then stress is what? Stress is force upon area. Again, force is in newtons and area is meter square. So force upon area is Newton meter up minus 2. So this would be B. Then latent heat, heat is nothing but heat only. So heat is measured in joules, and since it is latent heat, so it is per unit mass. So it would be joule per kg. So it would be C1, and power is nothing but energy upon time. Energy is nothing but mass into length. So mass into length is Newton meter, and you will divide it by time. So it would be Newton meter second inverse. So this is your D part. Okay. So by using a simple observations of these quantities, you can easily match this list 1 with list 2. Okay, so simple question. Moving ahead. Okay, so coming on to this type of questions, these type of questions are also very much asked nowadays in the means of assertion and reasoning. So let's study them. Two statements are given to you, and you need to tell both A and R correct, and one is false, one is correct, and it's correct explanation or incorrect explanation. So there are four options, and you need to choose the right option. So first is given time period of oscillation of liquid drop depends on surface tension, S, density, and radius. It is given to us that time period is depending upon these quantities. And then the definition of time period is also given. K root of density into radius cube upon surface tension power 3 by 2 is dimensionally correct, where K is dimensionless. So firstly, we will check that whether it is dimensionally correct or not. Because time period T dimension is T only, M0, L0 T power 1, and we will calculate dimension from here also. And then reason is given to us as using dimension analysis, we get RHS having different dimension than that of time period. So let us check the dimension of LHS first. So we know the dimension of surface tension is mt minus 2 because surface tension is force per unit length. This which study in surface tension chapter. So, unit of force is mass into acceleration. So mlt minus 2 divided by L. So mt minus 2 would be dimension for a surface tension. For density, it would be mass upon volume, so it would be ml minus 3. Then radius, it is L. So dimension of RHS would be the thing which you calculated. You will do all in all the quantities. You will raise it to the power of half because all the quantities were given inside the under root only. So m half L minus 3 by 2. Then L 3 by 2 upon mt minus 2 power 3 by 4 because it was given inside the underwood and it was raised to the power 3 by 2. That's why. So you calculate the dimension of RHS, you got it to be equal to this thing, and this dimension is not equal to dimension of time, which is M0 L0 T1, which is equal to M0 L0 T1. So since both the dimensions are not equal, so you can say that these two dimensions are not equal. So only your assertion is false, but reason is true because using dimension analysis, we are getting that RHS has a different dimension than that of time period. So only reason is correct, but assertion is wrong. So your D part is the right answer. Okay. So I hope you got the chapter. This is a very easy chapter among all the chapters which are given to you. So I hope if you master this chapter, you can easily solve the question coming from this chapter in your JEE-Mains. Okay. So, okay, so now let's end this session. Okay, thank you.